to share an example of how to annotate a lesson summary. This is a sixth grade example from Unit 4, Lesson 3. And sometimes we are taught how to annotate in a literacy classroom or in a social studies classroom. And how we do that in math might be a little bit different, but it's one of the ways that we can look at either notes that are provided or slides, or in this case, a lesson summary. And instead of reading everything and highlighting all of it, what are the really important things that we need to be able to know and kind of keep in our minds and practice as we go forward through the rest of the unit. So this is lesson 3, and this unit begins with thinking about what we know about division. And so I'm just going to kind of set the stage for us there. And I'm going to do what I would do with students if I'm explicitly teaching them how to annotate in a math classroom or annotate a summary or some notes. I would do this under a document camera like I'm doing now, with a collection of colored pencils or highlighters, preferably erasable if possible. And also highlighting to students, it's okay if you don't spell everything correctly. You're making notes and jotting down ideas and pictures that are going to help you really understand and make connections between the learning that you're doing and the learning that you already have. So let's get started. So for this lesson, I'm going to look at this in different pieces. So it says, when a situation involves equal-sized groups, it is helpful to make sense of that in terms of number of groups, the size of each group, and the total amount. Here are 3 examples. So because we've been working on division, and at times it's relationship or the inverse operation of multiplication, I've been hearing the terms like number of groups, size of each group, and total amount kind of over and over in the last couple of lessons. So that's going to clue me in that this number of groups, the size of the group, and the total amount is really kind of an important thing, right? So these are the pieces that I'm going to be looking for. And what I'm going to do here as well is over in the side, when I think about number of groups, size of a group, and a total amount, this often makes me think about kind of a number bond. And so if I had a number bond, I'm just going to like write myself an example real quick of what that might be. So if I have 3 as my number of groups, and my size of the group is 5. I have 5 things in each one. My total amount is 15, right? So if I am multiplying this and I'm dividing here, that kind of helps me know, okay, like this is that total amount. So I kind of like to think about it that way. I'm using a numerical representation. You could use a pictorial representation here if you wanted. Maybe you have 5 in the set of dice, or you have 3 groups of. We could also do this as a tape diagram, which is what we've been doing up until this point. I'm going to just draw that up here. So we know that we have 15 in all, and the size of each group, so the number of groups we have is 3, and the size of each group is 5. And that would be another way that I could represent that and kind of think about that as I go forward. And so we would often say to students, okay, so this is our quotient, and that's like the answer that we get in a division problem. Or at times it could be if we're dividing the total amount into pieces, we might think about that differently. So whether or not I remember the words quotient and dividend and divisor are maybe less important as having an understanding of the relationship between these numbers. And so just kind of think about that. So here are some examples that we're going to look at. Suppose that we have 3 bottles with 6½ ounces of water each. And I'm going to stop there for a moment and kind of take a look at the diagram or the tape diagram I have here. So this is showing me, okay, I have one bottle, and this, each one has 6½ So I'm going to connect these two pieces, right? So I know that each bottle has 6½ pieces. And there are 3 bottles. So I can see that represented here in these 3 bottles. So I could, if I need to, I could put second bottle. This is my third one. And each one of them has 6½ ounces of water. We want to know the total amount of water. And so how do I think about that? So I'm going to stop and kind of visualize that for a moment. I have 6½ 3 times. How much do I have? How many ounces do I have in all? So I could think about that as the multiplication problem, right? What is 3 groups of 6½ And I could represent that as a multiplication problem, 3 times 6½ So then I have an unknown. In this case, I have an unknown product. So I'm trying to find out how much in all. So that gives me an idea. And one other thing that I'm going to just kind of highlight is that this is going to be in ounces. So sometimes I like to write that and then ounces after. So it lets me know, like, and gives a specific quantity versus just an unknown. Like, is it a total number of jelly beans? Is it a total number of bottles? What is it? No, in this case, it's it's ounces is what we're looking for. So in order to think about that, I can find this amount by multiplying 3 and 6½ which gives us 19½ So I can put that together. So I have 19½ Now, how you solve that could really be up to you. You could think additively, or multiplicatively like we have here. So if we have 3 times 6, we can do that way, is 18. And then we can have 3 times 1/2 is 3 1/2 as well. And so that is going to give us 3 groups of 1/2. See, and I've made, like I said, I made a mistake here as I'm thinking it through out loud. So I'm going to look at this as I have 3 groups of 1/2. So I have 1, 2, 3, right? So I have one more whole. So that gives us 1 1/2. So that's going to be 19 1/2. So just kind of think about that as you're looking forward. So that's one way to think about it. If I was doing this through multiplication and I wanted to break that up into, to decompose the 6 1/2. So I could do it that way. The next one we're going to look at is here. So it says, next, suppose that we have 20 ounces of water to fill 6 bottles. So in this case, I have 20 ounces. I'm going to connect those two things. And I want to fill those bottles equally. So I have 6 bottles here. And I want to know how much is in each bottle. Okay, so we want to know how much is in each bottle. So I have to think about, okay, so what are some options? I know that I have 20 ounces in all. And I have 6 bottles. So I want to think about, if I'm looking at this as a part whole relationship, I can do that. So I have 20 in all, and I'm going to be dividing that by 6. what is this amount over here? That's what I want to know. And you can see that here as well. Now I have to think about, will that go in equally, or will I have a fractional amount left over? So we're going to look at that in this way, just how we did here. So we have 6 groups of what number make 20. So you can see that we have that same equation done in a slightly different way if we're thinking about the relationship between those two numbers. So the unknown value is one of the factors. So whatever that number multiplied by 6 equals 20. So we can find that if we divide 20 by 6. And so that quotient we can write, remember, one way to consider fractions is we can think about it also as division. So we have 20 divided by 6, or 3 1/3. So we would continue that as we go through and write little notes to ourselves, circle the pieces that are important, kind of connect those representations. And if it is helpful to you to draw another picture so that you can think about what those relationships might be, if you like using a number bond, or if you like the tape art model, I tend to like both of them. So sometimes I give like both examples just to help me really think about, okay, what are we doing when we are reading this problem? What's the piece that we're looking for and that we're trying to find? Let me know if you would like some other examples.